Many students find it hard to balance their work life and study. So our project aims to use large language models to generate personalized practical timetables that organize tasks and also distribute workload. Then let's talk about the input and data. For the first, you can input a simple sentence like a simple date range like November 17 to November 28 in 2025. Then our system will convert it into a formal scheduling period with clear start and end date. Also, we allow users to provide their routines, sentences to describe their routines, like when they get up and go to sleep, and also how they like to do their work. Then our system converts it into a user profile with including sleep schedule and work-life balance preferences. Then it will use to compare with our lifestyle DB, which includes habits of good GPA students that share similar routines like our user profile. It will help to evaluate and shape our generated schedule to encourage good behaviors. For activities, we have two types. The fixed activity happens at a specific time. It cannot be moved. For example, if you say I'm taking ECE 7086, and this is the first version that we extracted, use the large language models, then you could notice the start time and end time is missing. Then we use the extracted course code to query our course DB, and it will retrieve the start and end time automatically. In terms of our variable activities, this is a type that allows you to complete within a time window that fits your schedule. For this input, it will be reformatted into a variable activity with time and time estimated durations.
Our system has 3 agents, 2 databases, and 3 feedback loops. So the first user inputs the user profile, scheduling period, and activities, and the input processing agent receives it and processes into the process input. And if it doesn't meet the requirements, and we will display the input comments with the process input in the front end. And the user could modify their input based on these comments. And it will go through this loop again and generate another process input. Until this input is both confirmed by the agent and the user, then we can go to the scheduling agent. The scheduling agent would generate a draft schedule using both algorithms and the LLM. Then the critic agent will evaluate this draft, giving a critic score and a feedback. So if this critic score is less than 85, and the maximum iteration count is not met, we will loop back to the scheduling agent and doing another iteration and generate another new draft and have another new critic score. If this score is above 85, then we can accept it. So you can see if the maximum iteration is met and we still don't have at least 70 score of 70, then we will see there is no valid schedule for this input. So you may wonder, how do we calculate the critic score? So it actually has 2 steps. The first step is we check the unacceptable violations, which we call hard constraint. For example, if we have time conflicts, we will -5. And then if we have other violations, we'll minus other scores. And this score will be below 0. If the score is 0, then it means there's no violations. Then we will go to step 2 to check the soft constraints, which is the LLM evaluates the user profile alignments from 0 to 100 in 4 different criteria. So they will be added on together, and it will become the final score for the critic score. So we also have a user feedback to let the user see the actual generated schedule and score each category from 1 to 5. You can see here is a live demo. This is how our system to process the input and generate the input comments, and also to let the user input their user feedback. The For the schedule, it will be automatically exported to the Google Calendar for the better visualization and accessibility. We also see some unexpected issue that sometimes the weekend activities will be drift to the weekdays. So we dive deep into it, and we found it's actually because the agent misunderstood the time range of the variable activities sometimes, and also the user didn't take a closer look at the processor input and click the confirm.
In terms of the quantitative results, we use the same prompt to ask the baseline model and the FrameTime to do the evaluations. Using the critic score, you see that the FrameTime has much higher scores and it's pretty stable. We also invite friends to do the feedback, and our FrameTime has much higher user feedback scores. Yeah. Thank you.